Okay, next, let's talk a little bit more about slopes. Some information about slopes. Now remember, a slope of a line, it tells you how steep the line is. Okay? Look at this. This is not steep at all. It has a slope of 0. This is steeper. Picture if I put a marble, if this is a ramp and I put a marble here, it would roll down fairly quickly. That's even steeper. That would roll down even faster. Steeper. This is a special case we'll talk about. A cliff right up and down. It's as steep as you can get. Now also, whichever way it leans, oh gosh, I hope this is showing the right way. I think so, yes. For you guys. If it leans to the right, as you move from left to right, the thing goes up to the right. That means it's a positive slope. And a negative slope goes downward as you move to the right. So it goes down, like that. Okay? So, well, let me look at an example. You have this now. And this is the wonderful thing about video. So I can erase this pretty quickly because you can always just rewind it and see what this says. So I'm going to erase this. And let's say, I'm going to give some minimal information about a line so we won't see where it goes through. Let's say I have a line, I'm going to call it L1. All right. Actually, you know what? I'm going to make it a full thing. So if I told you y equals 3/4 x minus 2, you know the slope is right next to the x. So it's 3/4. And the top number is the rise. The bottom number is the run. You also know where it goes through. -2. It goes through on the y-axis. So the y-intercept is -2. All right, so now I have this wonderful grid here, which I did in permanent marker. Two things. I want to label the axes. This is the x-axis, and this is the y-axis. All right, and we'll put a scale. Here's 0, 1, 2, 3, 4, 5. So I'm going to say this is 5. Going the other way, -1, -2, -3, -4, -5. This is -5. Okay. Going up on the y-axis from 0, 1, 2, 3, 4, 5. This is 5. And going downward, -1, -2, -3, -4, -5. So I'm going to call this -5. Okay. Now we know you know how to graph this from the last video. First we put the y-intercept, and that's the little dot where the line goes through the y-axis. -2. Where's -2? That's -5. Here's 0, -1, -2. So it's going to go through here. And I'm going to use the slope to find one other point, or as many points as you want. It says it has a rise, and it's positive. So that's 3 up, and the run is 4. It's 4 to the right, because it's positive also. So 3 up, 1, 2, 3. And then I'm going to go 4 to the right. 1, 2, 3, 4. There we go. I got 2 dots. That's enough. I could draw it based on that. I'm going to draw more just to be accurate. Use the slope again. 1, 2, 3 up. 1, 2, 3, 4 across. Okay? It's going to look more like that. More or less. Okay? Okay. That's L1. I'll put a little label here. L1. Beautiful. Now, let's say I have an L2. -3/4 x minus 2. Okay, same thing. I'm going to go through -2. That's 1 point. But this says the rise is -3. That's 3 down. Y-intercept is still -2. So from here, to get L2, I'm going to go 3 down, 4 to the right. 1, 2, 3 down. 1, 2, 3, 4 to the right. I'll get another one. 1, 2, 3 down. 1, 2, 3, 4 to the right. Okay, so now this is L2. So as I was saying, the slope, when it's positive, it goes upward to the right. Where does this go? L1, positive slope, upward to the right. If the slope is negative, like we have here, it goes downward to the right. See? As it goes right, it moves down. That's a little bit about slopes. Let me talk about if I have another line, I'm going to watch this. I'm going to choose a different y-intercept. I'm going to create a third line. It's going to have a different y-intercept. Let's say it's a y-intercept of +2. Okay? Because we want to make the connections going forward and backwards. So I'm saying B is +2. And I'm going to say y, or the slope, is exactly the same as L1. So it's 3/4. All right? So what's the equation of that? Well, we know how to do this. You get y equals slope times x. So 3/4 times x. And then you add on the y-intercept at the end, +2. It looks the same as that, except the only thing is the y-intercepts are different. Well, you know what happens if they have the same slope, but different y-intercepts? There's a word that has funny spelling. I'll show it to you. We go 3 up, 4 to the right. 3 up, 4 to the right. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Okay, this is L3. You know something funny about L3? What about L3 and L1? They're parallel. L1 this is the sign we use for parallel. It's parallel to L3. They're not parallel to L2. They're both going to cross L2 at some point. So when the slopes are the same, two lines are parallel. That's another thing we want to remember. Let me erase this and put this down. If two lines have the same slope, then they are parallel. Has a funny spelling. Usually we see a double L at the end of a word. This is in the middle. And we have a single L at the end. That's just parallel. Parallel's gotta be different. And vice versa, meaning if two lines are parallel, they have the same slope. This makes sense. They're the same amount of steepness. If you walk up here and your mom walks down there and your brother walks up here, well, you and your brother are both going to be as tired once you get to this point. But if your she's having a good time because she's walking downhill. which is probably good for mothers because they're probably exhausted from raising you. Anyways, so two lines have the same slope and they are parallel. What about something that's flat? What about a line that's flat? I'm going to erase these because I did something here. Oh, it works. Baby. See, I put the grid in permanent marker, which I'll deal with later. I want one that's flat. Hang on, my phone's giving me some annoying message. Okay, like this. All right. Well, if I want to determine the slope, what's the y-intercept? It's right here. 7. And I'll pick another point it goes through right here. How about that? It's going from there to there. How much do I rise? Nothing. Let's call this L4. L4. Line number 4. The rise is nothing. What's the run? 3. Okay. Okay. So what's the slope? 0 over 3. What's 0 over 3 if you simplify that? 0. Nada. Bupkis. Zilch. There is no. Why? And that makes sense, logical sense. Because if a slope tells you how steep it is, this is as unsteep as you can get. This is just walking along the street, no hills, no nothing. What would that line look like? Well, okay, the slope is 0, and the y-intercept is 7. I did this wrong, sorry. Oops. M is for slope. M is 0, y-intercept is 7. Okay, let's put this in the equation. Y equals slope times x. And then we add in the x-intercept. Does that look funny to you? What's 0 times x? What's 0 times anything? Nothing. So this amounts to nothing. We don't even need it there. Whenever the slope is 0, this thing is completely flat. So it will have a y-intercept, but it'll be a flat line that goes through y equals 7. That's it. How about this? Call this L5. What's the equation for L5? Get out of here. It's got no slope, so I'm just going to leave that out. But it goes through y equals 3. That's the equation. How about L6? I'll write the equation. Let's draw it. Y equals -2. So all we have is a y-intercept. It goes through -2. There is no slope. So that's it. 0 slope. Okay, since I'm here, I might as well talk about this one. What about, well, this is a 0 slope. That's a positive slope. That's a negative slope. What if it is the worst? If you want to go up a hill, it's not this steep. It's steeper, 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 steeper. Ooh, the worst. Straight up and down. What do you call this slope? Ooh. Well, I raised this last because it's something we don't like. I don't know, mathematicians, especially math in high school, they don't like to talk about this dark subject. What is that? What is that? It's a straight line. Well, it's supposed to be straight. I'm just telling you, not the greatest. Here, this was L6. L6. So this is L7. And you know what? Let me erase all this other crapola. So we can just have a look at L7. Line 7. Line 7 is straight up and down, and we want to know, what does the slope like that look like? Okay. We know this too. I can erase that. The whole parallel thing. So we got parallel lines have the same slope. Positive lines go upward to the right. Negative lines have a slope that goes, the negative slope go downward as you go to the right. And then slopes that are completely flat, they have no x terms because the slope is 0. It makes it disappear. They only have a single number. Now, so let's look at this slope. Again, let's take 2 points. We can't use the y-intercept because this doesn't have a y-intercept. Oh, that's something very interesting. If it goes straight up and down, it doesn't have a y-intercept. So we have these 2 points. If I go from one point to the other, what am I doing? I'm rising by 1, 2, 3, 4. What's the run? How far am I going left or right to go from there to there? I'm not going left or right at all. It's only going up and down. So the run is 0. So the slope is 4 over 0. I don't even like to write this. This is such a bad thing. You don't do this in math. We don't have fractions with 0 on the bottom. When we do, we say they're undefined. Undefined. That is an undefined slope. If it looks like this, it will not even have, it can't be fit into the y equals mx plus b type of form. Why? Well, the slope is undefined. What am I going to do? Replace m with the word undefined? That looks stupid. Is there a b? No, it never crosses. It's parallel to the y-axis. It's not going to cross it unless it's right on top of the y-axis. But no, it's... So what we do is, the only thing that we use is, where does it go through on the x-axis? It goes, this one goes through 3. So it has L7, its equation, go away. Okay.